Hey, today we're going to we're going to take a look at section 9.4, and we're going to start talking about what are called vectors. And today we're just going to look at vectors geometrically, try to understand what they are, what it would mean if we took a couple different vectors and added them together, and today's just an introduction. Okay, so first off, so there's a lot of reading, so I apologize. So a vector is a quantity that has both magnitude and direction. Okay, so magnitude means there's a certain amount of strength to it. Okay, it could be very, very strong, it could be very weak. And then direction means, well, it's going in a certain direction. Okay, so examples like force. If you push something, you push it with a certain amount of strength, and also in a direction. You can push something left or right, you can push it up, you can push it down. Okay, gravity. That's a vector. It's pulling down at a certain amount of force, and the amount of force here on Earth is different than the Moon, is different than another planet. Okay, so that magnitude can change. Wind can be blowing north, it can be blowing south, it could be blowing at 10 miles per hour, it could be blowing at 25 miles per hour. It could be a hurricane. Okay. Or a tornado. So there's a lot of different amounts of magnitude, which is strength, and then also the direction that the force is being applied. Okay? Geometrically, when we talk about a vector, we use an arrow. The length of the arrow represents the magnitude. So the longer the line, the stronger it is. And the arrowhead indicates the direction. So geometrically, we use what is called a directed line segment. Okay, so in geometry, you deal with lines. So this is a line that goes through PQ. So that would be, we write that like this. Okay, you could have a line segment that starts at P and goes to Q, or from Q to P. There's no real direction as to which way it's going, but we would call that PQ, and we'd put a line segment on top of it. And then you have what is called a directed line segment. So this is going to appear like a ray from geometry, but it's not, because a ray is kind of like a line. It goes infinitely in one direction, and this does not. This has a starting point and an ending point, and the arrow is showing you the ending point. It's showing the direction that we're drawing this. So it's a segment, it starts and stops, but it's directed. It's going in a certain direction. So P is the initial point, Q is what's called the terminal point, and this is our directed line segment, PQ. Okay, that's going to be important. The magnitude of the directed line segment is the distance from point P to point Q. So it's the length of the line segment. The direction of P to Q is from P to Q. A lot of times when we talk about vectors, so this is a directed line segment, a lot of times we just use like a vector, a lowercase letter with like a little arrow on top. So this is vector V. So this is directed line segment P to Q. This is vector V. And if they're the same, then we could just call this a vector. We could say vector V is equal to PQ. So these are examples, as you look through the notes, these are examples of vectors. This is vector W, this is vector V, over here there's vector U, so they just like to use this little lowercase symbol, instead of having to know what the initial point and the terminal point is. Two vectors are equal if they have the exact same magnitude, so they're the same length, but also they have to be going in the same direction. So over here, you'll see this line segment goes like 1, 2, 3, 4, and goes up 1, 2, 3. Okay, this one 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1. So these are all going in the same direction. They're all the exact same length. So all of these vectors are equal to each other. Something we're going to do here when we turn the page is we're going to add vectors. So think of this as two forces. So this is where we're starting. So I have an object, and I'm pushing it this way, and then that object is getting pushed this way by another force. So it got pushed from here to here, and then got pushed from here to here. Well, we could have applied one force that would be the sum of these two forces, and that would have just pushed the object from here straight to here. So this is called vector addition. So I have vector v, I have vector w, and then this would be the sum of those two vectors, which is vector v plus w. So if something started off here, where would it end up if you applied these two forces together? Well, it's going to end up over here. This is our terminal point. This is our original initial point. Down here, just real quickly, vector addition, if you're adding two vectors together, vector addition is commutative, which means it doesn't matter what order you add them. If I'm going to add vectors v and w together, it doesn't matter if I do, so this is my initial point. It doesn't matter if I follow vector w, and then from here I follow vector v, or if I would have started by going in the direction that vector v travels. So look, these two v's are the same, they're parallel, they're the same vector. It's just this one I'm applying vector v first, and then I'm applying vector w. I still start in the same place, I still end in the same place. This one talks about the fact that vector addition is also associative. Associative means you're adding three things. It doesn't matter if you group like the first two together and then add the third one, or if you grab, if you like add the second and the third one together and then apply the first one. If you're adding three things together, you're always going to end up in the same place. Here's my initial point, there's my terminal point. So this is the sum of all those three vectors applied together. That's all that's saying. All right, on the top, we're going to talk about what a negative vector is. If v is a vector, then negative v is the vector having the same magnitude, exact same length, but going in the opposite direction. So this vector is going up and to the right, this one's going down and to the left. If you almost think of it as like slope, it's going up 1, 2, 3, it's going over 1, 2, 3, 4. This one would be going down 1, 2, 3, and then would be going left 1, 2, 3, 4. So it's traveling in the exact opposite direction. Okay, so that's what a negative vector is. And that is helpful when it comes to subtracting. Okay, what does it mean to subtract a vector? Well, really, subtracting a vector is just adding the opposite vector. So that's how we're going to think of it. So down here, we're going to draw some of these, and when we get to subtraction, we're just going to add a vector that's traveling in the opposite direction of the vector that they give us. Okay? Last thing we need to talk about before we can do this, what is called a scalar. A scalar is, so right here, it's a quantity that has magnitude only. So there's no direction, there's just like a certain strength to this. So like for example, mass, length, time, okay, mass, something, or weight, think of weight, how heavy something is. There's no direction to that. There's no direction to time. You may think, okay, well, time moves forward. That's not what we're talking about. Okay, time doesn't travel north, south, east, or west. Temperature, it could be hot, it can be cold, but there's no direction to that. Okay, so that's what a scalar is. And we can multiply a vector by a scalar. So this is vector v. This would be vector 2v. So it's a vector that's twice as long as the vector that they gave us. So this vector goes 1, 2, 3, and then up 2. So 1, 2, 3, up 2. This is the original vector. And then if I go 1, 2, 3, 1, 2, so this is v, and then this is another v. So this is 2v. That's all that is. Okay, a vector could be negative. So again, multiplying by -1 just takes this vector and makes it go in the exact opposite direction. Okay, instead of going up and to the right, it goes down and to the left. Don't get this confused with like slope, where you're going, like this would be positive, and then so you want it to go negative. It goes in the exact opposite direction. It's not like one's going up and one's going down. If one's going up and to the left, it is going down and to the right. It is going in the exact opposite direction. Okay, so here's what we're going to do. Take a look at these examples down here. We're going to draw these. notice this is not, there's no like XY axis. This is just a grid for us to use. So we can start anywhere drawing these. I always say kind of take a look at the vectors, try to get an idea of how the overall shape is moving, and that's going to tell you where to start your picture. For example, I am supposed to draw, so we're gonna take 2v and we're gonna subtract w, and then we're gonna figure out what that total sum of that vector addition is going to be. So I'm going to do 2 v's, so v's going up and to the right, and then another v is also going to go up and to the right. And then I'm supposed to go the opposite of what w does. I'm going to add the opposite of w. Well, w goes down and to the right, so this is going to go up and to the left. So overall, I'm going to kind of go this way and then this way. So I'm going to start down here somewhere, anywhere. And then I'm going to apply v. So v goes 1, 2, 3 to the right, and then up 2. 1, 2, 3, up 2. And then I'm going to draw, so that's vector v. I like to put a little v there. And then I'm going to do it again. I need 2 v's. So from where I stopped, that's where I start. 1, 2, 3, 1, 2. So there's another vector v. And now I'm supposed to add the opposite of w. So again, from where I stopped, this is where I'm going to start drawing the next picture. Now the next picture is going to look like this, except the arrow's on the other end. So it's going to start here. It's going to go 2 to the left and 2 up. So 2 to the left and 2 up. That is negative w. Now, that's not my answer. My answer would be the one vector that's called 2v minus w that would start here and end here. That is vector 2v minus w. That's it. That's what we're doing. Okay? Look at the next one. I've got v, so I'm starting with v, so I'm going to draw this. I'm going to go up and to the right. And then I'm going to do minus 2w's. So w goes this way, but I'm going to go the other way, and I'm going to do it twice. So again, I think I'm going to overall start down here and kind of end up here. So we're going to start down here somewhere. So v, 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. That's v. And then I need to subtract 2 w's. So I need to go 2 of these, but in the opposite direction. So I need to go left 2, up 2. Left 2, up 2. There's a w. Left 2, up 2. There's another w. And if you leave it like that, you just lost a point on a quiz, okay, or a test. Our answer is that vector in that direction. Okay, it's going, this was my initial point, and so that's going to be the initial point of my answer, and that's the terminal point of my answer. So this is vector, and sometimes you have to move it, v minus 2w. All right, why don't you give the last one a shot? So I'm supposed to go v, I'm supposed to add 2 w's. So we've done nothing but subtract w's, so make sure you go you're following the path that w goes. And then we're supposed to subtract this u. I will give you a hint. You're probably going to want to start kind of up and to the left for this to not fall off the grid or something. Okay, so start there and see if you can draw this. Press pause and then press play when you're done. All right, and that should be your answer. There's v. I added 2 w's. W goes down to the right, so I went down and to the right. But then I was supposed to subtract u. So then I needed to draw a vector that was in the opposite direction of u. U went right 1 and up 3. So I went down 3 and I went left 1. So that's the opposite of u. And so this is my total vector, v plus 2w minus u. Okay? All right, so give your take a look at your worksheet and let me know if you have any questions. Thanks.